Good afternoon to all of you. This is our second class on structural analysis. Let me go to what we have from the previous lecture. Okay, and the main thing I like to start the lecture. We come to the study at Surrey University of Technology. We have the final design project called the Capstone Design Project. This subject has the learning objective to review all the knowledge the student has from the first year to fourth year over here at Capstone Design Project, to use this in the design of a building. For example, if you have this kind of the sketch up for the project, and the School of Civil Engineering is going to ask you how you're going to design this building. So first one, you got to understand the project requirement. Understand the project requirement. That means you're going to draft what the project is going to build for. For example, is going to be the school. For example, is going to be for the condominium, those kind of things. Okay, and then you're going to study the architectural plan, and then you are going to transform the architectural plan into the structural plan, in which we can use your or our knowledge to work on this project. Okay, so in this way, you got to take a look at this sketch from the architect, and then you require to use the knowledge of engineering graphic, graphics, to read this one, to check to the structural plan. For example, we start by taking a look at this portion of the wall. Okay, and then we can sketch up this size. So we start by this one. This is going to be the light blue, and then we have this green and this green. So you may sketch. By sketching this, you're going to do a lot of scaling. You got to use a proper scale, okay, to do this, and then go further like this. You get onto this side. You're going to draft the floor plan of this building, and then on the back, you may take a look at this, and then you have the back for this way, and then another side you get is on this way. So in the combination, you get the floor plan of this building in the shape like this. Okay, on the floor plan, you're going to check the position of the wall and the column. For this one, you're supposed to start by checking this wall. So this is going to be the wall. Usually this wall is used to resist the wind load, the lateral load. And then you have 1, 2, 3. You have 1, 2, and 3 column. Okay. And then alongside this, you have 2 more column, and then on this side you have this 1, 2, 3, and the wall. This 1, 2, 3, and again the wall that's taking care of the lateral load. Okay, and then along this one we're supposed to have the column, and most of the column will project in the same line. Okay, and in the drafting of this kind of floor plan, you got to set up the reference line. For example, this is going to be the reference line, and this is also going to be the reference line. And then you say this is going to be line A, B, C, D, and E. And over here is maybe line 1, 2, 3, 4, and 5. And then you put the position of the column, okay, into the grid line that you sketch it out. And over here, there is the what? The elevator shaft. Okay, you may put the elevator shaft on this portion. If there is 2 elevator shaft, you're going to have this kind of elevator shaft. And then you got to put the line of the column. Okay, now you got to have the floor and the line of the column. Between the column, you got to have the beam. For example, for this one, okay, if you select to use the reinforced concrete floor, okay, you're supposed to have the beam connect between the column, and by doing this you got to connect all the column by the beam, and your structure start to be follow the grid line that you just put kitchen. Okay, now what you are going to put is what is the symbol that's going to represent your floor, your beam, and your column. By doing this kind of floor plan, okay, and then you select the type of floor you are going to use. And if you go back to the theory of structure, there has, you may call the floor as the slab. You have what? One way slab, and you also has the 2-way slab. You can check it by using the knowledge of what? Of theory of structure, chapter 1. Okay, you can read the short side, you can read the long side. Okay, it's depend on the way you use it. If you use the ratio of long per shot, if this long per shot is larger than 2.0, that's one going to be the one-way slab. The slab is going to have the shape like rectangular, long rectangular like this. Okay, if you has the L over S less than 2.0, you will get the 2-way slab. Okay, if you check this one going to be the 2-way slab. If this one is 2-way slab, you're supposed to put the symbol like this. Okay, if you come to take a look at this one, you may get this one as the 1-way slab. This is the symbol of 1-way slab. This is the symbol of 2-way slab. The ACI use the different notation. The ACI use the opposite to this. The ACI check the short per long. Okay, that means if you less than equal to 0.5, it's going to be the 1-way slab. Okay, SOL short over long is larger than 0.5. That is going to be 2-way slab. And you know the two-way slab has the load distribution for the short side and for the long side. One on the short side, the load distribution will have this shape, triangular, okay, and the long side will have trapezoidal shape. And then what you need to set now, you set for the floor or the slab, okay, you consider the area, you consider the ratio, okay, and then you set the floor as slab 1, slab 2, whatsoever. You also need to set the slab, and then you will transfer the load on the slab into the beam. And now it's depend on the area. That's your beam taking care of the load distribution area. And you set the name of beam to be B1, B2, whatsoever. And then depend on the column. For example, if you take a look at this column will taking care of only this area. Okay, this column will taking care of the load from this area, and this column inside it is going to taking care of a larger loading area. Then for the column, you also need to set the name as C1, C2. Okay, and you do every floor of this building. For example, example, you go back to the floor below it over here. You did the same thing, okay? And then now you're going to do the what's so-called the load transferring from the roof, okay, to the foundation of the building. So this way you will have a chance to consider all the load transferring on this structural system. The transferring on what's so-called, this is going to be the structural system, okay, SYSTM. And then you may finally go to the foundation, and then you will take a note is F1, F2, whatsoever. It's depend on how many footing you have, okay. And then following this, you got to do the third step. After you get the floor plan, you got to do the analyze and design of the structural members of the structural members. There are floor, there are beams, there are columns. But before you can do this analysis and structural of member, you got to go to the building code. Okay, in Thailand, we have the ministerial code for the estimation of the live load and so-called the dead load and also the live load. You're going to find the minimum loading that's required to put into your structure. You got to follow the building code because the building code is by law, is obligation. Okay, for the dead load, usually you can compute by the cell weight. For example, cell weight of the structural member. Okay, for the cell weight from the floor, cell weight for the beam, cell weight for the column. However, for the live load, is depend on the function of the building. For example, we be talking about the kinder kindergarten. That's for the kid. So the high building code require at least 150 kilogram per square meter. However, if you design the university, the live load gonna change into 300 at least kilogram per square meter. Okay, then you will distribute, you get the loading that's applied to the floor. You use the concept of load transferring the load from the floor to the beam, load from the beam to the column for each floor. And finally, they all will transfer to the foundation. Okay, and then when you finish load transferring, you can do analysis of the structure. On the first pass of this analysis of the structure, the Capstone design project require you to use structure, to use the knowledge that you learn from the engineering static, okay, from the mechanics of material, from material testing, from the theory of structure, and this course, structural analysis, okay, is require you to determine, for example, what is going to be the axial force maximum on the member, is maybe the shear force, is maybe the maximum moment. And then when you use this, you may use the hand calculation. You are going to use a lot of hand calculation in the course. Or over here, you also may use the computer program called Structure. Okay, the Structure, TOR. You can download this from the website, our civil engineering school of civil engineering website. You may search it by using the Google Classroom. And again, when we're talking about the design, now you're going to study many courses. For example, the RC1, that is for reinforced concrete 1. That's based on the working strength design. Okay, or the RC2, that is going to be the ultimate strength design. Okay, you may follow the Engineering Institute of Thailand design code. Okay, now I put another one that is going to follow the design code. Design code is different from the building code. Design code is not law. It's produced by the professional institute like this one. Okay, and some people may also prefer to use for the ACI, American Concrete Institute design code. Okay, but in Thailand, I recommend you guys to use the EIT code. Okay, for you who work in America or international company, you may use the ACI. You also study the steel design. Okay, that is going to be another code. Okay, the EIT has the steel design for working strength design most of the time. Okay, or you may also use the LRFD. That is another way based on this design code. So you may put all the designing procedure here to put into the software like Excel to help you to design the structure. And then again, go back to the engineering static. You got to provide the detail of your design. Okay, the detail of your design. And by doing that, you're going to be ready to build the structure. Maybe it's the reinforced concrete or the steel design. Or you also can study another course, for example, the pre-stressed concrete design. Okay, that's teach by Ajahn Anop for this university. And then when you finish this, the capstone design project also require you to use the knowledge from the course of what the building design. Okay, after you finish the design course of pieces, concrete, RC1, RC2, timber and steel design on the 4th year of the first trimester, you will have this building design. On this building design, Professor Mongkol will teach you to use the computer program such as the ETAP, okay, or the program called SAP 2000. Okay, now you will use this program based upon this structural plan and do the modeling in the computer, and then you will get the result, and you're going to compare the result you get with the result from your manual calculation. That's called a capstone design project. That's required like a year to work on this kind of project. And I would like to inform you guys about this and be prepared for this. That means every courses that you take, you got to have the knowledge. You got to have the knowledge about the course. You cannot say, Ajahn, I forgot. No, you cannot. And you also need to have the skill, okay, for this thing to work on this kind of project. And after finish the capstone design, you're going to be at least close to what's so-called the engineer, even though we call you as the young engineer. Okay, anyone have any question about what I'm explaining to you? I like to inform you guys about the big pictures of the courses you are going to study. You are going to study over here for the 2nd year, for the 3rd year, and for the 4th year. And you use the whole knowledge to work on the last big project. Okay, and now we come to what? We come to the structural plan. We come to what's so-called the floor, the beam, the column, the footing. That's called the structure. Okay, we can classify the structure by taking the form. The form may be like the slab. Okay, the form of slab gonna be something like this. Slab gonna have the shape like this. Okay, if you consider the form of the beam usually in the horizontal direction and subjected to the force. If it's in the form of the column, okay, it's going to have the form like this. Okay, if we consider the function, okay, the function is the duty. That's the form gonna take. The function of the structure may be the function as the cast room, the function as the meeting room, okay, the function as the commercial building. Those kind of function used to specify the life load from the code. Okay, now let me go to a typical structural member. First one, we start from the roof. If you come to the F4 or F5 building at this university, and then you take a look at the roof, okay, and you will see the lot, the steel lot, that has the X shape crossing between the structure. Okay, this one we call it as the tilot. The tilot is used to resist the tensile force due to what? Usually due to the lateral load from the wind. Okay, or the earthquake load. Okay, for the shaking of the ground. Both of these we call it as the lateral load. Lateral loads that usually come from in the horizontal direction like this. Okay, and this will increase the stability of the building. You will learn how to design the tilot in the course of steel design. Okay, อาจารย์คนอาจารย์เอกวุฒิ will teach you like this. And if you come to the structure like this, this is a steel frame. It's called the gable frame. Okay, this kind of the gable frame. In the construction of this, we start by building the footing on the ground, and the footing may have the pile if the soil is not strong enough to resist the forces. And then you erect the column. Okay, you put the column in position, and then after you put all the column in position, you put the beam across it. Okay, and you weld them together to connect this one and an example of the steel gable frame. Okay, the joint here is going to be the rigid joint. Okay, that means this joint can take the moment. And then what we have is after that you put the purlin. You put the purlin cross the roof. Okay, you put the purlin cross the roof. Also on the sides of the building, you also put the cladding. Okay, this is going to be the cladding. This is going to be the cladding. Let me put the white one over here. And then you also before finish this one, you're going to put the tilot that I just mentioned into this. The tilot will help to stabilize the structure from the action of the lateral loading. Okay, and then on the design of this frame, you guys gonna transfer the force from the roof sheet. Okay, from the roof sheet, this roof sheet into the purlin, and then the frame will act by the vertical load, the dead load, and the live load from the another kind of what so-called up and proper load combination of dead load and live load. Okay, it's maybe the live load, also roof load, and going to combine with the wind load. Okay, the dead load is going to be the weight of the structure. Okay, and what this step is not enough. There is the wind. Okay, the wind may blow in any direction. For example, if I assume the wind blow from this way, okay, what we have is the structure gonna push, okay, into it. That means the X basing here gonna take care of that. Okay, and when you design the structure, they also have another wind that's going to blow along the side, okay, of the building. So the load combination going to be very important for you to consider. But for the example, I want to focus on the tilot. okay, that's used to tie the structure together. If you take a careful look, there is another X basing on the last row of the frame. Okay, this will taking care of the wind and the earthquake if it has. Next, we have the structure over here. Okay, this is what, if you take a look of this one, this is lifting to put into the position on the highway bridge. Okay, highway bridge. In front of our university, there is the construction of the bypass. Okay, there is the highway bridge there. They built the beam. Okay, the beam can be, for this one is precast RC beam. Most of the time is precast pre-stressed concrete beams. It is more popular than precast RC beam because pre-stressed concrete beam is more effective, okay, than the reinforced RC beam. And the beam also in the building from the previous building, that's going to be the cast in place, okay, from the previous one, RC beam, okay. No matter is the precast or is the cast in place, most of the time the beam, when it put in the horizontal direction, like this one, we put it over the pier, okay, over the pier to transfer the load from the floor to this pier, okay. And this beam is a kind of what we have studied before, is going to be simple beam, okay. And many times we put it into the full name of statically determinate beam, in which we have studied them from the engineering static, mechanics of material, and theory of structure. Okay, and during the working in the bridge, most of the time this will subjected to uniformly distributed load from the floor of the bridge. But for somehow, if you consider this one, this is another kind of loading. So when you design this kind of precast pre-stressed concrete beam, you need to consider this is the load during the construction. This is the load during the operation. Okay, you're going to cover every kind of loading. The load here, we call it as the transfer load. Okay, and then from the knowledge of what? Of mechanics, engineering static, mechanics of material, you can determine what so-called this one. This is going to be the shear diagram of this beam, and you can compute what so-called the moment diagram of this one. You're going to find this one for V max. You're going to find this one from the M max, and you use the M max to design the beam. And then later you check the design, the section with the V max. If you can record it, it's going to help you, okay. And usually if this is, if this is W, if this one is W and the length here is L, you will know that this is going to be WL over 2. This is minus WL over 2. The maximum moment here is going to be equal to WL square over 8. Okay, you can go back to what you have studied. Okay, and then when you're talking about this, if the beam is a form of reinforced concrete beam or the piece beam, you may know that most of this beam has the rectangular section, and this beam usually reinforces by steel. Okay, why this beam usually reinforced by steel? Because concrete can resist compression very good. Okay, but concrete cannot resist the tension. That's why we put the steel reinforcement or steel rod reinforcement into the beam to taking care for the tension. Okay, and then if there is the also steel, just put it like this. Okay, this one will taking care of the compression. Most of the time, the top portion going taking care of the compression, and the steel going take care of the tension. And then you also has the stirrup. Okay, this is going to call the stirrup. Okay, like เหล็กปอก in Thai. This stirrup going to taking care of the VMAX. Okay, so when you design the reinforced concrete beam, or even you design the piece concrete beam, you're going to find the size of the section first. What is going to approximately the B? What is going to be approximately B the H? Most of the time we use the experience to set it up. If you don't have experience, for example, if you're going to design the beam over here, you can go to the 3 แยกปัก to take a look at this kind of the beam and estimate it. Okay, we use the experience most of the time, and then you design for the steel reinforcement, how many steel you're going to put in, and then you design for the area of the stirrup. Okay, that is the way we did. We also sometimes has the steel section. Okay, most of the steel section may has the I section or W section like this. Okay, for this one, most of the time the top flank and the bottom flank is going to use to taking care of the moment, and we use the web, okay, of the steel to taking care of the shear. Okay, so the next slide is explain how the wide flank taking care of the loading, the web here usually used to taking care of the shear, and the flank, the top flank get the compression from the moment, the bottom flank get the tension from the moment. Okay, this kind of design of the section is a genius one. And then if you go to the company like SVI, BSBM, or SCG, this kind of steel company built the steel section with this kind of wide flanked beam. Sometimes they also make it as the hollow. Okay, there is many kind of structural steel, but most of the time you will see we will not use the solid section. We will not use the steel with the solid section. Most of the time we use it as this kind of hollow section or this kind of I and W section. Okay, you can read what I'm explaining from the word here, and this is the example of the I section. that's used to build the bridge again. This time, the bridge didn't build as the previous one by the precast, pre-stressed concrete beam. This bridge built by the steel. It's up to your choice. It's up to the country. Okay. In the US, a lot of bridge built by the steel. But in Thailand, we prefer the concrete more because most of the time our structure is subjected to the water. So the maintenance of steel is going to be more. Okay. For the reinforced concrete, like I said, the main reinforcement, okay, will resist the tension. The portion, the top portion for the positive moment. If this one is subjected to the positive moment, the concrete on the top going to taking care of most of the compression, and then the steel here, okay, will taking care of what? Of the tension. And then the stirrup, most of the time we use the stirrup, that's closed loop, not be like this, the closed loop like this, okay, to take care of the shear force. And then that's it for the shear force. Stirrup is for the internal transverse shear force. And then next, we come to the structural member that is in the vertical and subjected to the axial compressive load. For example, I took this column from the canteen, Salaloy canteen. Okay. In the application of this, you may imagine the force from the what? From the floor will transfer to the beam. Okay, the force. And the force applied to the beam, okay, will transfer into the column. And since there are 4 of the beam, so you're going to have 4 forces applied to the column. Most of the time, we assume for this kind of short column, we assume the short column is subjected to only the compressive load. Okay, now, and then if you consider the section of this kind of column, okay, is going to look very close to the beam. They are going to have the main reinforcement, okay, and they also has the stirrup to tie the main reinforcement to work together. By doing this, the ability, okay, if you follow the ACI code, okay, you may have the strength of this one, okay, equal to another kind of factor times 0.85 F times sub C times AG minus AS and plus AS, and then yielding strength of it. Okay, this is a kind of load discharge factor. It depends on the column. Okay, if it's rectangular, it's going to be a value. If it's circular, it's going to be value. Okay, that is about 0.8, something like that. By doing this again, you got to approximate the size of the column. Use the experience. If not, you may go to look at the structure that's close to the one that you design. Okay, use your experience. So you can compute A sub G equal to, for example, this is going to be B squared. So this one you know. And the strength of the concrete, for example, you may use 240 kilogram per square centimeter. This is also known. If you specify the steel from the material testing, you may say, okay, we use the F sub Y with the yielding of 2,400 kilogram per square centimeter. By doing this, if you estimate the P sub U from my first PowerPoint, that's the load transfer from the floor to the beam to the column, is going to be this one. Okay, it's depend on what you are going to use, working strength design or ultimate strength design whatsoever. It depends on, is this a way to compute the P sub U based on the subject of RC1 or RC2. But anyway, if this one, no, you can compute the A sub S. Okay, and then you can specify the area of the steel used in this column, and the A sub S must be larger than equal to 1%, 1% of A sub G. It's going to be larger than this. If you compute it less than this, you got to increase this to 1%. Okay, I'm going to connect the knowledge you're supposed to know. You're going to find, oh, Ajahn, I'm so confused. Don't worry. Later on, when you finish this course, go to the reinforced concrete, and you come to my YouTube, you will see what I has sketched the knowledge for you. And when you go to do the capstone design, and then I refer back to what I'm saying here. Okay, I will feel good. Hey, you forgot that. Hey, you forgot that. You don't say, Ajahn never teach me. Okay, now go to another kind of column. It's called the beam column. Beam column is a kind of the beam, is a kind of column that's subjected to both axial load and moment. Okay, the design of beam column separate from the design of column. You got to make sure you are going to design the steel. That is another subject. But design the beam column. If you go to the reinforced concrete, there is a way to design the beam column. But the way, the methodology of design are different. Okay. Anyway, I got to teach you because the design code for this beam column are different. Depend on the material you are using. Okay, the beam column has the stress distribution on the section like this. It's different from the column that's subjected to only axial load. That is going to be uniformly distributed load. Okay. Okay, this is an example of the frame. If you analyze the frame, okay, the frame will has axial force. The frame will has the moment inside it. The shear force inside it, and the frame will have the moment inside it. This is the moment diagram of the frame that's subjected to gravitational load, which is the dead load and live load, depend on load combination. But this show you the example that most of the column subjected to the bending. But practically, we design the column based on the axial load first. Okay, and when we finish design it with the axial load, after we finish the design of the beam, we finish the design of the column, and we combine the beam and the column together and do the frame analysis. When we did the frame analysis based on the section that we design, and if we found that the value of the moment and the value of axial force is large, okay, we got to redesign it. But practically, we start by the column subjected to the axial load. This is going to be the later part, okay? And then we come to the task. The task is very typical. If you are the student staying at SUT, you go to the Salaloi canteen. Okay, you take a look at the roof of the alloy, you will see the truss. The truss usually fabricated by using steel. Okay, the member of the truss is two-force member. If you build it properly for this one, the loading from the roof will transfer to the purlin. Okay, and the reaction at the purlin will act on the joists of the truss. So this truss will subjected to the vertical load like this. Okay. Under this one, the structure will resist the force, and the member of the structure, the bottom, will taking care of the tension, and the top, the member going to taking care of the compression. Okay, and then they call them the two-force member, the member that's subjected to the tension and the member that's subjected to the compression. The ways to design the tension and the compression member are different. So when you study the steel design, Ajahn will teach you to design the tension member separate from the compression member, because the compression member will subjected to buckling. Okay, it's different from the tension. Tension have no buckling. This member may subjected to the tension, compression, and I say again, they are different in the design. Okay, and most of the time, if the load that apply to this member are equal, and this member also have equal length, most of the compression member will be equal. So most of the time when you select the top member, okay, you will select it with the same side as the tension member. Okay, but for the diagonal member, you may select another side depend on the internal forces inside this yellow member. Not only the roof, there is the bridge. Very large bridge can built by the steel truss. Okay, a lot of bridge that built in the past, usually for the train that's across the river, built by the truss, and they are good because the truss is appropriate for the long span structure. If you're going to design the bridge across the river, the truss is the most effective structure, okay, in the design of this kind of structure. Okay, and also if you actually consider the truss, you may explain why it's more effective than the beam. Truss is like the beam, but truss has the spacing inside it. Okay, so the truss is light, and the truss has a large depth. So the moment resistance of the truss going to be very large. So truss behave in the same way as the large girder. Okay, that means usually it's more effective than this. The top member going to take care of the compression, the bottom member going to take care of the tension. This is a way we use the material more effective compared to the beam. Okay, again, if you come to SUT, okay, you may see this is going to be the roof truss. This is going to be the roof truss. And this roof truss is look very simple. Is going to be 2D roof truss. But if you come to here, this also the truss, but is going to be the 3-dimensional truss. We are going to have the way to compute the 3D truss. If you go to my textbook or if you go to the Hebrew textbook, we can use the metric method to analyze the 3D truss. Can we analyze this one by hand? It's going to be very difficult. Okay. But over here, Ajahn, this one also the 3D truss, right? Yes, it looks 3D truss, but lucky, very lucky. We can reduce this one for the 2D truss. For example, if we consider the truss here, okay, we may take a look at this one and then you start to setting up. This is going to be the support. This is going to be the support. By this way of thinking, you may just take the portion of this truss, okay, and just consider it as the 2D truss, or we may call it in the Hebrew textbook as the planar truss. Planar truss. Okay? Okay. There are a lot of things to talk with you today. Actually, I spent an hour talking about the structure, not finished yet. A little bit further, we study the cable in the theory of structure already, right? The cable has advantage when we build it for very large structure because the cable resists the force by developing only the tensile force inside it. Okay, by doing this, we got to put the cable with the proper support, and then we use the anchor. The anchor. This is the vertical steel. Vertical steel connect the girder of the bridge. Connect the girder of the bridge with the anchor. So the force, very large force on this girder will transfer to the green anchor. Okay, this is going to be the bridge girder. The force from the girder will transfer to this one called the anchor, and the anchor will transfer the load to the cable. Okay, the cable over here. That is a system, and then it's very effective. It can use to build very large bridge. For this bridge is like the span nearly 800 meters. Okay, and we also have some bridge in Thailand have this kind of shape. If you go to my theory of structure PowerPoint, we have the bridge at Mương Lei, or very close in Kolat, you may go to Bum Ta Lua. That has the bridge. That has the suspension bridge. This one we call it suspension bridge. Okay, it's different from the King Lama 8. Okay, that's called the cable stay bridge. You may go to the Google and searching for these two bridge and read it for your knowledge. Okay, it's very, very, very important for you guys to understand different type of structure. You are a civil engineer, right? You got to know everything. And then I went to Australia once and I found this arch bridge. Okay, this arch bridge is connect to the foundation here. Okay, by this way, this bridge that's connect over here, okay, that's connect over here, transfer the loading to the arch by what? By the, again, the anchor. Okay, for this portion is used anchor, but for the other portion, for example, for this portion, I just consider only this portion is transferred by the column. Okay, that is another kind of building, very beautiful. The arch, when it's subjected to the force like this, okay, the arch will produce compression. So the reaction of the arch will have the form like this. The arch resists the force by developing compression inside it. So the design of foundation very important. Okay, and then arch also has many types of arch. If the arch is parabolic arch, the parabolic arch will have only compression force. Parabolic arch you can see a lot of parabolic arch. If you travel in the US, there is a lot of parabolic arch bridge. Okay, but if the arch take the other form such as circular arch or triangular arch, the arch will subject not only the compression, okay, the arch will subject with the shear and bending moment. So when you're talking about the arch, you're going to consider type of arches. If you prefer to study about this beautiful structure, Google it. There are a number of them. And we also have this arch in Hua Lamphong. If you go to Hua Lamphong 10 station, this is going to there you will see the arch that built in King Rama V. That's it, 100 years ago already. Arch, very beautiful and very efficient, a high efficient building. And then next, we come to the frame. When we come to the frame, this kind is structure, like I previously said, is going to be the beam connect with the column. Okay, for this one, you build the column. Okay, you cast this column. After you cast this column, you cast the beam on different kind of column. Okay, after you finish casting the beam, you may put the floor. Okay, the floor on the beam. The load transfer from the green floor, green slab to the light blue beam and to the column. By this way, if we consider the beam and the column working together, like I said, after you finish design of each structural member, you may require to put them together as a frame to analyze it for taking care of the special loads such as the wind load. And for this one is going to be the rigid joint. Okay, this frame is going to framing to each other with the rigid joint, the column and the beam. Now, this one will strong, very strong, transferring the forces between the column. This is close to the real structure, more than we decided. That's why from the start, we just decide, analyze and decide it piece by piece. And later, after we we know the size of the beam and the column, we put them together and reanalyze it and check that the size of the beam and the column are able to resist the forces. Okay, that's we estimate from the structural plan. And another one over here is the steel. Okay, and for the steel section, the joints may be the pin. You are an engineer, okay, many times you have a chance to design a simple steel frame. When you design a simple steel frame, you may have a chance to do the modeling of the structure. You can be able to model the support to be as the pin, or you may model it as the fix. This is fix support. This is pin support. And if you weld this one, very rigid welding, this is going to be the rigid joint. Okay, this is going to be the rigid joint. If you just connect the beam, okay, to the column, okay, by using bolt. When you use bolt, that is going to be the pin connection. You are an engineer, okay. As the engineer, you the one that do modeling. If you modeling, you got to give the detail to this structure properly. For example, if this is the pin, okay, the support here supposed to be simple, okay, but if this is fixed, the support may have the pie here, and then when the column joins to the foundation, you may put the steel stiffener into it. Okay, this is going to be the fix. Okay, this is going to be the pin. And the connection also, if you like to connect it as the fix, you got to weld it, okay, properly. If you like to make it as the pin, you may use the bolt, okay, to bolt this one together. They have a lot of detail of this. As an engineer, you require to know this kind of thing. Okay, and then the large stadium. Many people here like to watch the football. They play in the large stadium. Most of the large stadium may have the roof that's built by surface structure. This is a kind of structure that is in the 3 dimension. So when they work, they're going to work together in the form of 3-dimensional shell. Okay, they work in the 3-dimensional shell. The load gonna transfer by using the material in different kind of direction. That's for the stadium. That's for a big conventional hall. That's for the airport. You will have a chance to work on this one when you are posting to the senior engineer, or if you are the young engineer, you are very good luck for this kind of big project. Okay, the surface structure will resist the axial force, resist the shear, resist the moment in 3 dimensions. And the last one, we have this kind of structure like a tent. Okay, this white thing is the membrane. Okay, when we took the word of membrane, this kind of 3D surface structure is a special one. Okay, the membrane is only taking for the tension. Okay, this is from the Denver International International Airport. They built this one to look similar like American Indian 10, American Indian 10. Okay, it's like a symbol of Colorado. Colorado have a lot of Indian, as New Mexico, as the Arizona, but Colorado take this one as the symbol of the state by putting this roof into the airport. Okay, this also very big project. When it's finished, it was the second largest airport in the US. That is about 25 years ago when I studied there. Okay, come to what we have for today. I show you the picture of highlights building. Many people consider the highlights building represent the advancement of the nation, okay, and the richness of the nation also. In Dubai, many years ago, the king of Dubai, okay, built the Burj Khalifa Tower, and then they have some problem with the money, so the Burj Khalifa Tower changed to the Kingdom Tower. It's reached the 800 something meter. No, this is a Kingdom Tower. Sorry, this is in Saudi Arabia. Okay, and this is Burj Khalifa. Sorry, that is 800 something meter. This is built in Dubai. After Dubai finished this building, Saudi Arabia said, if Dubai can do so for 828 meters, Saudi Arabia built a 1,000 meter to get higher. So that's what I said. Some people put the highlights building as the representation for the richness of the country. But anyway, the standard said every country that has the tower of 800 meters considered a prosperous country. In Thailand, we didn't have much tower taller than 600 meters. As far as I know, there is one building in King Rama the 9. Okay, that has about 600 meters. Okay, that's what I talk about the type of structure. I spend a lot of time review this thing because when you reach the capstone design project subject, okay, when we refer to everything I said, at least I put everything to you guys already. You guys must has the what's so called the lifelong learning. You got to put everything that I just mentioned. You may search it, study it to get the knowledge of this thing. Okay, I did put for the first slide about the word load. Okay, and I also said the load can be dead load and life load for the big picture. Dead load is the permanent load most of the time, but life load is not. Life load changed by the function, changed by the time. But the life load or dead load will come from the building code that provide the minimum design load. Building code is a must because it's specified by government agency. It's the legal code. Okay, you must follow this. But it's the minimum. You can put larger than this, depending on the function that you like to put into your building. Your building just maybe only the commercial building. Okay, a lot of people didn't do much in the commercial building. They just put like a store to commercial building. But if you use this commercial building like a car repair shop, the load will be different. Some also use commercial building just for what? Just for a house. Okay, that didn't take care of much load. But when it's used as the car repair shop, you got to expect. If not, if you use that commercial building as the car repair shop, the building may be damaged due to the load that's put into the building. Okay, and the other way, you may what so-called strengthen this commercial building to be as the car repair shop. What so-called the strengthening. Okay, and then we have also has two big building code in Thailand. One is the Bangkok building code, which is the modern one. Okay, is legal to use in Bangkok. We also have the national building code. Okay, building code. That's very old one. Okay, it's 20 years older than this. That's for 25-22. That's why in Thailand we use a lot of design code from the Engineering Institute of Thailand to help us in the design of structure. But the load, you got to follow this. If you are in some states of the US, you got to follow this, or you got to follow this, depend on the state. That specify the code. Okay, but in Thailand you use the pink one. Now, since the building code are usually old, technically there are the engineering institute like the EIT, Engineering Institute of Thailand, to develop the technical detail of the analysis and design regulation for modern structure. Okay, and this is not the legal stuff, but you can follow this one, especially they design the structure with a safer when compared to the building code. Okay, and then you got to follow in Thailand here. In America, you may use the American Concrete Institute. Okay, for the reinforced concrete. If you build the highway structure, you got to follow American Association of Steel of State Highway and Transportation Office. Okay, that is for the highway. Or if you work for the steel, you got to follow the American Institute of Steel and Construction. Okay, this is a design code. Even though it's not legal, but it's modern, it's going to provide a safer design compared to the building code. And you got to strictly follow it. For the dead load usually is the permanent weight that's put on the structure. Most of the time is the old weight. Permanent weight such as the chair, okay, such as the furniture. Sometimes they call this one as the superimposed load. Okay, remember this word. You're going to increase this superimposed load with the own weight or self weight load to produce the total profit. The computation of the dead load comes from the type of material. Okay, depend on the density. This is depend on density. If you know the volume of it, you can compute the load. And if it's in the form of wall, in the form of roof, in the form of ceiling, okay, in the form of floor, the unit is going to be the force per square millimeter. And like to ask you again, if you know this, go back to your house. Can you compute the net load of all the component of your house, of the wall, of the floor, of the beam, of the column? Can you? That's supposed to be a good assignment for you guys to type it, but you don't need to turn it to me. Okay, but for practice to make the skill, okay, to estimate the dead load from what you can see. Another one, the live load is change in magnitude and location, talking about your house. Okay, sometimes you have the people in the room. Sometimes you don't have a people in the room. Sometimes when your house has a wedding ceremony, they are going to have a lot of people in the room. That's kind of people that's in the room, out of the room, is going to consider as an example of the life load. Okay, it's maybe the weight of the student in the classroom. It's also maybe the wind load. It's also maybe the traffic load on the structure. Okay, and then you got to consider for the building load. Is depend on the function of the building. Okay, if it is the kindergarten, bathroom, restroom, the load is going to be half of the university building, school building, or commercial building. This is again is the at least is the minimum. You cannot use lower than this, but you can use larger than this, depend on if you have the commercial building and then you're going to build it as the car repair shop. You may use 1,000 kilogram per square meter if you like. Okay, if it's the beach, you're going to follow the Department of Highway of Thailand, okay, to design that kind of bridge. If you work for the Department of Highway, you just follow that kind of code. It depends on if you take a look at this loading, you can see this is going to be the largest load. If you design the highway such as Mitrapap Highway to northeast, or you design the Phet Kasem Highway to the south, or Phahon Yotin Highway to the north, you're going to use this kind of thing. But if you going to build a rural road, okay, and that rural road will have only this 10-wheeler, so you just decide it based on the maximum ability or maximum classification of the load you are deciding. Okay, and don't forget the load have the vehicle is the impact when you move into the bridge. Sometimes it has the impact. Don't forget talking about the impact. You can follow this. Okay, and next the wind load. The wind, when the wind blow, wind cause the what's so called the mean wind pressure. Okay, like this one. Okay, you can see the flag blowing by the wind. Okay, I took this picture many days ago, and you can compute the mean wind pressure by this equation, in which the V is going to be the velocity, and this load is going to be the air density. So it depends on the unit you are considering. If you're working on the SI, just follow this equation. The mean wind pressure will be in the unit of Newton per square meter. If you follow the Thai standard, you use this equation. and you got to know the wind can blow anyway. So the consideration of the wind must be in many cases. Ajahn Mongkol said in the program he used to compute the wind load, the wind pressure, it has a total of 28 cases. So 28 cases, we don't do it by hand. We use a computer to do it. The wind can cause the failure of the building like this. Okay, and if you just follow the Bangkok building code, you work in the Bangkok area or you work in the municipal area, that's adopt Bangkok building code, like the one I think Nakhon Ratchasima municipal code also adopt some of the Bangkok building code. You may use the wind here, okay, as the minimum. This can use to the building of 10 story. But if you build a high-rise building of 30 story, no, you're not. You're going to use the computer program that Ajahn Mongkol use. For example, you may use the ETAP or you may use the SAP 2000 and another program such as the Revit from Autodesk. Oh, you're supposed to apply for the student license for the Autodesk. It's as a free student license for you guys to practice for the Revit. Okay, and when you compare this kind of thing, you got to compare this kind of thing. If you use the program and the program produce the load that's smaller than what we have here, you must follow this. Okay, it's illegal. But if the program generates larger result compared to this, you can use that for the safe design of your structure. Okay, and then I just for your reference, okay, this is the wind speed compared to the different height. If you start by the first 10 meter, your wind is going to 0.5 kilonewton per meter. That's around 100 kilometer per hour wind. That's quite a lot, right? But if your building is tall, you are going to be 40 meter. The wind is going to be 100 kilogram per hour. But if you watch television, you may see sometimes hurricane, typhoon can produce the wind as much as 300 kilometer per hour. That's kind of thing. You got to go to the computer program to analyze your structure. Okay? And earthquake. They are not much important in Thailand. Only some portion of the structure of the Thailand that must consider this. Okay? If your structure is stiff, for example, if your structure is so strong like this, there is no problem. Okay, but if you design your structure is so flexible like this under the earthquake or wind load, it's no good. So we prefer to design the building with very stiff column, okay, to protect from the wind and the earthquake. We won't like to have the column with the less stiffness. So the column is supposed to be big. The easiest way to say that your column will be very strong if your column is big. Okay, and there is the portion in Thailand that you got to consider it in Kanchanaburi, in Tak, in Mae Hong Son, in Chiang Rai. Okay, this pink color, you got to design the structure because this is going to be the prone area, earthquake prone area. Usually you got to put about 20% more reinforcement into your beam and column to make your beam and column stiffer than normal design. Okay, and also there is a soil pressure that you guys going to study in the subject of soil mechanics. Okay, you're going to estimate what the pressure gonna act on your wall. Okay, you will study the soil mechanics to get the soil property to estimate the load, and then your design this your design this retaining wall, okay, by using the design of foundation engineering, okay, foundation engineering, because this going to connect, okay, this wall. If you model kit, this wall supposed to be the vertical like this, and then you must put the foundation into kit, and under the soil mechanics of material and foundation design, you can approximate the loading that act on this retaining wall, okay, and you also need to design the foundation. If the soil under this retaining wall is weak, you got to put the pile, okay, to strengthen your foundation. Okay, if the soil very strong, you don't need to have the pile, okay, and then you also need to consider the hydraulic pressure. If you going to design the weir or design the dam, for example, like this dam going to take care of the pressure from the water. When there is water, okay, on this level, the pressure of the water will act to the wall of this weir. So is this your duty as the water resource engineering, water resources engineering, okay? You need to design this kind of structure. So in engineering, in civil engineering, we didn't much only focuses on the building. Don't misconception on that. There is the weir, there is the dam, there is the water retaining structure, or even the retaining wall. That's you guys supposed to consider it. And loading that act on this kind of structure is going to be complicated. You're going to study the hydraulic, okay? That is going to talking about the pressure of water in the pipe, in the weir, in the dam, and you study the hydraulic, hydraulic engineering for design the structure, the weir, the dam, the pipe, okay, to send the water. And where the water flowing into this is come from another subject called the hydrology. Okay, you study where the water come from. You can see the link between this kind of thing, between the soil mechanics and foundation engineering. That is another set of geotechnical engineering. And then you can see the relationship between hydrology, hydraulic engineering. This is for the water resources engineering. Okay, engineering. That is the three main things for the engineering. Structural engineering, I start with it. Geotechnical engineering, that's just finished. And this water engineering. And all of this kind of engineering must follow the course of what? Construction management. Okay, when you construct this kind of project, you're going to use the subject here to control the construction as you decide. Okay, it also has the construction estimation okay, to estimate the cost of the building. And while you are building structure, you're going to do the surveying, okay, that's you got to do the survey the area for the design of structure, survey the area to build the structure. This is the leadership of civil engineering. If you decide the dam, if you have a bad design of the dam cannot resist a big water, or you predict wrong, or from the hydrology, the pressure that water push into the dam is too large, it's caused the dam to failure, okay, and then it's going to cause a lot of damages, even though lives. So you got to prevent it. Our life, our engineering work require a lot of carefulness to understand things like this, and I like you guys to understand every field how they related to each other. Okay, I spent 2 hours explain to you guys because of that. Understanding each other will enhance your learning ability, and you can connect everything like a spider web. Okay, and let's add quarter. Not only that, thinking about the roof, the roof of the building get what? Get the sunlight during the daytime. It's hot. When the structure is hot, the structure will expand. Okay, when the structure expands, there is the load inside it. Okay, and next, not only that, at the end of series of structure, we consider the structure. Some people get this examination. Okay, we have a beam like this, statically indeterminate beam, and then there is a settlement of the foundation due to the movement of the soil. Your structure used to be like this, and then it's bent to be like this. Okay, it's bent to be like this. That's caused the shear, that's caused the moment inside the beam. So the differential settlement sometimes cause the crack to the structure like this. This is occur in the dormitory Suranivet 9 in our university. We spent nearly 20 million baht to repair and rehabilitation this structure. Nowadays it's safe already. We finished strengthening and repairing this structure like 15 years ago. Okay, and also the load must be combined each other to get the critical load closest to the real load. Okay, we didn't have only the dead load, we didn't have only the life load. There are many kinds of dead load and many kinds of life load. So if you follow the interior ministry regulation, which is the legal stuff that I just mentioned, this is the full name of it, and if you design the structure based on the ultimate strength design for the reinforced concrete building, when you first step of the design, the first step you do it only this load combination. You design the structure for the beam, for the slab, for the beam, for the column, for each floor of the structure until you get the foundation. Okay, and then you may combine everyone to be the structure, and then you may check the resistance of this structure, okay, by the application of the wind load. If you analyze the structure basis on this load combination and you found that the moment and the shear still lower than, that didn't cause your structure to be failure, lower. then didn't cause the failure of the structure. The first design will be governed. But if you analyze the structure and you found that the moment and shear due to the load combination in some structural member larger than your first design, you're going to be redesign that members, not the whole structure, just some of them. Okay, there are many kind of load combination. This is for the reinforced concrete building basis or ultimate strength design. If you bases on the working strength design, the load combination will be different. Okay, so it's depend on the design code you use, like this one. Okay, or this one you supposed to. Then I have about 10 more minutes. I will go really quick because of what? Because I did teach you guys this issue already. If not, you go to the playlist in my YouTube of my YouTube. Okay, in the theory of structure and chapter 8. In the first part of chapter 8, I talking about the statically determinate structure and statically indeterminate structure in detail already. Okay, this is the same slide. This whole thing is the frame. This frame is constructed by the concrete. Okay, when it starts by the cast in place reinforced concrete, what do we have? The structure will connect each other continuously and it's going to be statically indeterminate. This one is the steel, and then you can see the connection. You can see the connection of this steel bridge. Connect continuous. When structure connect continuously, it's going to be statically indeterminate. That means the unknown นะครับ unknown is maybe unknown reaction and internal forces and moment larger than the number of equation of equilibrium. In short, it's only this. Okay, you just check. For example, if you have this beam, okay, you're going to have what? Under the application of the force, you have the reaction. This is first unknown, second, third, fourth. So the number of unknown is going to be 4. The number of what? Of equilibrium is 3. So you have the degree of indeterminacy. We call it DOI equal to 4 minus 3. That is going to be 1. From the consistent deformation, we will select one of these as the redundant. And I said, I prefer to select this one. It's going to be easier. We use this as the redundant force, okay, as the unknown, FORCE. And this method that we use in the theory of structure, we call it force method. Is the consistent deformation method. Okay, we call it as the force method because we use force as an unknown. Okay, we have a lot of indeterminate structure, but we also have some determinate structure. Advantage. Okay, indeterminate structure use less material and has small deformation because when you compare these two beams, the determinate will have the moment of PL over 4. The indeterminate can distribute the moment to the left and to the right support, so it's reduced by half. And due to the constraint at the support, the fixed supports constrain the beam a lot. The deflection on the indeterminate beam is only 1/4 of the determinate beam. Okay, and then you can see this smaller deformation, smaller moment, and it's also produce the cantilever construction. For example, if you use the cantilever construction, the waterway here, the boat can use it easily, and it's going to be very tough if you're going to set the formwork when the water like this. Okay, the cantilever construction method is a kind of very good method for large structure, and this advantage is more complex to analyze and design. In some cases, you got to provide a good foundation, a good connection, and then since you're gonna provide a lot of things, so it's going to be more expensive than determinate structure. Okay, you got to put a lot of bolt to make it fix. And the differential settlement will produce forces in the determinate structure, in the indeterminate structure. Temperature change also. Okay, if the structure is determinate like this, this is determinate, this is determinate, the structure won't have the internal forces, but the function also lost the same thing. Okay, it has crack, it has settlement. Also, when the load change, the deformation of the structure change. If this one is the reinforced concrete, in this way you got to put a lot of reinforcement. In this way, extra reinforcement, and also you put this way and this way. So for the indeterminate structure, don't forget to consider different load pattern. Okay, in your analysis and design. Okay, let me go further. The deflection. If you consider the deflection also the basis in the analysis of the structure. For example, you just come into consider this structure that I'm going to show you. Stop sharing. You may see I have the beam here. If you put the force onto the beam will deform. This is called the deflection. The movement in the vertical direction we call vertical direction. And over here there is the angle. We call this as the slope. Okay. If this is simple beam, the deformation is this one. Very simple. Okay. Again, if I change this one into a beam with overhanging, and I put the force here, you see, before this, the beam just curve, and here is a straight member. Okay, this is no moment on this part, so it's straight member. And if you put the force like this, see, this is going to be the deflection. So if you like to draw the deflection, you're gonna have some homework to observe this kind of thing. Do it at your home. Okay, do it at your home. Okay, and then if the structure is more complicated, okay, it's also going to use this knowledge in the next chapter, inference line of indeterminate structure. Okay, Musler-based law. You go back to theory of structure. There are the people who set up the Muller-based law principle. It said, if you like to draw the inference line of reaction, for example, this is A, this is B, this is C. Just release the reaction of this point out and leave it for 1 unit. The shape of this beam is going to be the inference line diagram of R sub A. If you put this, you're going to draw the inference line diagram of R sub C. Just leave it 1 unit. This is the inference line of R sub C. And again, If you like to draw the inference line of R sub C, you got to lift this one, put this one still the same. Lift this one unit. This is inference line diagram of R sub C. So, accepting from you using the deflection diagram to put the reinforcement in the theory of structure. The inference line, the elastic curve will use in the inference line diagram of statically indeterminate beam as I show you over here. Okay, next week we will study it. We will draw this diagram. The inference line diagram of statically determinate beam going to be the curve. If you recall the Muller-Based law for the design of this precast concrete beam for the highway bridge, this is simple beam. Release this one, lift one unit. The inference line diagram of determinate is the straight line like this. You can remember it. For the inference line diagram of R sub B is going to be the shape like this. Okay, that's all I like to tell you about the deflection diagram. A little bit more. Let me go a little bit further. I'd like you guys to go to the chapter 7 of the theory of structure and review how to draw the elastic curve. Okay, like I just showed you, the deflection diagram or elastic curve is important in this subject. Okay, the vertical called deflection, the slope called for the angle. Okay, and elastic curve, you also know about it already. Go back to theory of structure. Go back to my YouTube. This is your homework. Okay, of structure. Go to what? Go to chapter 7, the deflection. Okay, we did talking about this already. That is your assignment. Go to both chapter 8 and chapter 7. Okay, and the detail of this steel connection, I like you guys to remember it. I like to talk it over here because during the capstone design, during the steel design, you got to provide this kind of connection detail. Okay, and go to all of this. This is the, I mentioned about fixed or rigid joint connection already. This is a pin connection. Okay, rigid joint connection going to have the same rotation. If it's a pin, it's going to have a different angle. Okay, and go back and review how to draw this kind of thing. You will see it easily. Okay, and then there are two things. Displacement method, we use displacement as the unknown. Okay, to solve this kind of problem. This one we have studied for mechanics of material, and we will use again in this subject in the chapter of slope deflection method. Okay, and then go back to the way you know about it. Fourth method, you have F sub B as the redundant, and then you may stop my video and try to solve this one by yourself. Okay, video can stop anytime. Okay, in short, for the force method, you use force unknown. Remember the redundant. Okay, and during the solve, you use the compatibility condition, and you use this force displacement relationship. And now this subject, you use the displacement method. Now we use the delta and zeta as the unknown. Now the equation that we use to help us is the equilibrium equation. Okay, and also the force displacement method. You got to study, remember this table. Okay, and this force method also, please go back to the chapter 8 and review it. This is going to be the basic of our next chapter. Okay, and then the degree of indeterminacy, I did show you guys for the example already. This is a good example to check about the degree of indeterminacy and the degree of freedom. Okay. When the degree of indeterminacy is high, the degree of freedom is low. Degree of indeterminacy is for the force method. Degree of freedom is for the displacement method. For this kind of structure can solve for the displacement method easily. This kind of structure can solve by the force method easily. So it's depends on the type of structure, see. And then the last one, point load, produce the moment diagram as the straight line like this. Uniform load produce the moment diagram as the curve. And when they combine together, the moment diagram will be straight line for point load and curve for uniform load. And then at the end of this, moment is 0 for pin or pin roller. But for the fixed, the end will have the moment. That is everything for you guys, okay, to take a lead at this. Stop video and read it, okay? And this is the end of chapter 1. And